Welcome to this Maths Heroes video. My name's Christine. Today I'm putting it in the context of calculating change, but this is an example I did with some of my adult students in plumbing. And we were looking at subtraction or difference. And what I would say was I asked them which one's easier for your brain to work out. So here I've got the 32. Here I've got the 18. So the yellow box is my equal sign. And I would say, actually, we're trying to find what Nemo is. The first different one there's 34 and 20. So what I've actually done is I've added 2 onto both of those. So this became 20, this became 34, and I knew that the difference was 14. I did not change the answer at all. The other ones, so if I've got 32 and 18 again, you can see 18 is just a smidge over half. And what I did this time was I took away 2 from both of them. So there's -2, there's -2. And so now I've got 16 and 30. And I might know that the difference there is 14 as well. Note again, I didn't change the answer. And the last one, so if I've got 32 and I'm at 18, I might know, there's Nemo, I might know that I can hop another 2 to get to 20 and then hop another 12 to get to 32, which is a total of 14. But also, I could say, well, if I'm at 18 and I hop 4, I can get to 22, and then I know from 22 to 32 is a hop of 10, and there's my 14 as well. The whole point being, I have not changed the answer. So Nemo didn't change in any of those examples. When we're calculating change, sometimes I give extra so that I create a friendly number to give change. So, for example, if I spent $5.10 and I only had a $10 note, I could get $4.90 change. So, to myself, I think, oh, yeah, and 90 cents gets me to $6 and another 4 gets me to 10. But what if, so this is my Nemo here. What if I actually just gave an extra 10 cents to both of those? And so now I've actually given $10.10. And what the change will be is now $5 because now I'm going, the difference between 5.10 and 10.10 is $5. That saves me a lot of coins. Likewise, if I spent $16.50 and I had a $20 note, trying to find my change, well, I know $16.50, 50 cents gets me to 17, so this must be $3.50. Don't really want all those coins. Let's see, what about if I added $1.50? So if I add $1.50 and $1.50, now I'm paying $21.50. And the difference between $16.50 and $21.50 is this $5 here. So this is very different to the first 3 examples that I did not change the answer. So in this case, I am changing the answer. Let's do another one. If I had, let's see, what about if I had $34.95 and I had $35, right? When I lived in Holland, 5-cent pieces were actually used so often they actually sometimes might run out or have very few left. So what they would say, instead of saying, "Can you give me 5 cents as change?" they would say, "Hey, if you give us 5 cents, an extra 5 cents, we'll give you a 10-cent piece back." So here is the 10 cents, and I would actually give $35.05. And that way I would get a 10-cent piece back. Doesn't matter what you're doing. Um, any numbers, whether they're small or large. Like for example, if I was at $4.15 and I had a $20 note, if I gave that extra 15 cents, so let me just put this in first. So to get to $5 is 85 cents. So I would be receiving $15.85 in change. Don't really like all of those coins. So, but what if I actually gave that 15 cents? So I was paying $20.15. So now I'm getting back $16. So the difference between 2015 and 415 is $16. This is a visual that gives students a way to be able to see this idea of giving more to get back a whole number, if you like. I find it works really, really well, and love your feedback on it. If it works for you, let me know. If it doesn't work for you, still let me know. But I hope you've enjoyed watching and seeing some different thinking. Maybe test it out on your own thinking or your own students. And I look forward to seeing you again in the next video. Thanks for watching. Bye for now.